Hey guys, I'm Mr. C and welcome to our third day of summer math. Today's focus is quadratics and factoring, more specifically factoring quadratics. This is something that seems to come up again and again and again on a lot of the tests you're taking, but factoring is something that's going to come up again and again and again throughout all of your math classes, whether it's Algebra 1, Algebra 2, I don't know, pre-calculus, calculus, any of those math classes. Factoring is all over the place, so it's important that we learn it good now. Now, the very basics, right? The factors of 10. Now, what I like to do is the up the ladder, down the ladder technique, right? You get a number like 10, right? And I'm saying, what numbers multiply to get 10? I always start with 1, and of course the number. And if it's an even number, which it is, right? 2. All right, and then what you're going to notice is you're going to end up in the middle pretty quickly, and you're going to have every single factor pair. Now, I know that's not very impressive factoring 10, but let's take a bigger number like 48, right? So you've got 1 and the number 48, right? Is 2 a factor? Yes, it is, because 48 is an even number, right? So we'll go with 2 and 24. 3 is 3 a factor? Well, a little trick. If the digits add up to a multiple of 3, which they do, 4 plus 8 is 12, which is a multiple of 3. Well, we know that 3 is also a factor. You might need your calculator to figure out that 48 divided by 3 gets you 16. 4, well, if 2 is paired with an even number, which it is, right, then I know that 4 is also a factor. 5 will not be a factor because, as you know, the number would have to end with either 0 or 5, and it doesn't. 6, I know 6 is because I know 2 and 3 both are, right? And so what you guys will notice is that, much like I said you would, you end up in the middle very quickly, and not only that, you end up in the middle with a complete list of factors, right? So this up the ladder, down the ladder technique is a great way to make sure that you get every single factor possible for a particular number. All right, so now factoring quadratics, we came up with kind of the simplest quadratic we could come up with. Most of you guys recognize this as the product of x plus 2 times x plus 3. And those of you guys that are saying, well, how the heck did you get that? Well, what you need is you need something that's going to multiply to get you 6, right? So, 6, what are my factors of 6? Well, I've got 1 and 6. I've got 2 and 3. That's basically it. Which pair is going to add to get me that positive 5? Right? You look pretty quickly, you're going to see 2 and 3, which is why that is the factored form of that quadratic. All right, now solving, right? This looks to be very similar. Some of you guys might say, oh, it's the same problem. Not quite the same problem, but it is very, very similar. As you know, this in factored form is x plus 2, x plus 3, but then it's asking you another thing. It's asking you what values of x will make this equation true, right? So in other words, if either this is 0 or that is 0, right? You multiply 0 times anything, you're going to get 0, right? So what would 0 this first thing out? Well, if I made x negative 2, right? Negative 2 plus 2 is 0. It doesn't matter what this would be because it would automatically multiply to 0. Or if I made this negative 3, because negative 3 plus 3 is 0, which it wouldn't matter at all what this is. If I multiply by 0, I would get 0. So those are my two solutions to that particular equation, right? So factoring and solving, right, going hand in hand, right, when you can factor a quadratic as two binomials, like many of you guys have done. Okay, so now this is just quick notes, kind of showing you in a nice organized way with some visuals, how do we factor, right? Now, this is very similar to what I just talked about, right? Very similar problem, right, where you're going to multiply to 8 and you're going to add to negative 6. So what I would do here, right, is I would just figure out, well, what are my factors of 8? And there you have it, right? Notice they even go a step further and tell you the positive and negative factors, right? And which of these would add up to get you negative 6? And there it is. Okay, now, of course, that was a very simple case because, as you know, right, these lead terms is going to be x times x because x times x is the only thing that's going to get you x squared, right? So that's a slam dunk. Now, the reason we call this a harder example because it's less clear. Well, 2x times x is going to get you 2x squared, but where's the x go? Where's the 2x go? And how does this whole thing, factor out to get you, well, Anyway, let me show you how we would kind of go about doing this using the box method. The box method, many of you guys are familiar with. Those of you guys that have taken Algebra 1, and especially Algebra 2, are very, very familiar with the box method. But what you have to do basically is what we want to do is just like we did here. If we call going from here to here foiling, I'll call from going from here to here unfoiling. So how the heck do we get this into a factored form, right? And that really lies the challenge, right? So the way you would do it, and they're kind of breaking you down step by step here, you again have to multiply to get -6, but also that lead coefficient has to be 2. So now we're going to kind of tell you the tricks, right? So the trick is, right, you need factors that add up, excuse me, yeah, that will multiply to -12. Because what you do is you multiply, when you're using the box method, you multiply the A value and the C value, right? And that's how you get your -12, right? So if I get my -12, right? Right. Now what I'm going to do is I'm going to list my factors of -12, right? So I've got, well, I guess 1 and 12, right? And I guess, okay, I'll do it all out, right? So either one of these could be negative, right? 2 and 6, right? In order to get -12, I guess either one of those could be negative as well. And then 3 and 4. And again, either one of these could be negative. But what combination is going to get you that plus 1x in the middle when you factor it out, when you FOIL it out? And the truth is, it would have to be this right here, right? And that's kind of what we showed you. We skipped a couple steps here. We're saying you multiply those together to get you -12, which is why that was even in the running. But then when you add them together, you get that +1, right? So that is why, right, we put -3x here and the 4x there. That's why we did that, right? So the box method, again, I know this is a review for most of you guys. The easiest part is the first thing, right? The lead term always goes here, right? And the last term, right, always goes in this box, right? The mystery is what goes in these two boxes. Right? And that is how we do. We multiply the A term and the C term, or the A and C coefficient, I guess I should say, go up the ladder, down the ladder, like I showed you how to do on the warm-up, right? And you figure out, well, what will add to get you that middle term, right? Now, once you're here, then it's just a matter of factoring out the greatest common factors. In each case here, we would get 2x, right? 2 of the greatest common factor of the coefficients, then x. And here, I guess it would just simply be x because, well, you can't, no common factor between 2 and 3. And then up and down here, it looks like you would have a -3, right? And then across here, it looks like you would have a 2, right? So if I'm going to write this in its factored form, right, what I would do is I would have 2x minus 3, right, times x plus 2. And if you ever want to know if you're right, all you got to do is FOIL it. So I'm going to actually check my work here. So I've got 2x squared when I multiply those first terms. I've got plus 4x as I multiply the outside terms, minus 3x as I multiply the inside terms, then finally minus 6 as I multiply those last terms. And yes, those two middle terms here will combine to get you that plus 1x that you were looking for. Okay, so anyway, that is the box method, right? I know many of you have seen that before. If this is the first time that you've seen it, feel free to review the video or just reach out to me or Miss McNally whenever you want. We'd be happy to help you through the box method. Again, that's when you got to use the box method or another method if you have another method. But if that lead coefficient is not 1, it's not just simply x squared, right? You can't just do the unfoiling thing. You gotta, well, you might be able to if you're a very sharp math student, but most of us need to use a technique like the box method in order to figure that out. Okay, so here, what are the solutions to this equation, right? And again, this is an official MCAS question I think some of you guys may have seen before, but what you're gonna do, this is one that you will solve by factoring, right? The lead term, 0, The lead term, very straightforward, would be x. There's only one thing that would be, right? The way I choose to do this is I go up the ladder, down the ladder, 112, 2, 6, 3, 4. What combo will get me plus 7? Oh yeah, there we go. So it's plus 3, plus 4. But folks, we are not done. Don't fall for the trap. What will zero this out, right? X could either be -3 or -4. Those are your two solutions, right? That is why A is the right answer and D is not, right? Don't fall for that trap. Okay, same kind of thing here, right? Basically, it's just asking you to factor this quadratic. Basically, what I would do here, right? Same thing that I just keep doing, except I'm going to go -84. Now, if you want to, I know Miss McNally always does this. Miss McNally is the best in the business, so why not do what she does? She actually writes the factors twice, just to be super clear, right? So you get 1 and 84, right? If you're going to be negative, either one of them could be negative, right? Again, we're trying to add to get you that +5, right? 2, yes, because we have an even number, 2 will work. And as Miss McNally always does, showing both either could be negative. 3, it's a little tricky, but you know what? If I add those up, it's 12. That's divisible by 3, right? So that's going to be a factor. You might even need your calculator to do this. It's okay. You know what? And I'm going to use my calculator just to play it safe. So what do we got? We got 84 divided by 3, 28. You know, some of you guys I know could just do that in your head, but most of us can't, right? So either one of those could be negative. Oh, sorry about my handwriting there, you guys. 4, yes, 4 works because 2 is paired with an even number. And even though this seems like this is taking forever, we're going to meet in the middle faster than you think. 5 doesn't work. 6 does, and the reason I know 6 does is because 2 and 3 both work. Of course, that might be another one. That would be 14, because it'd be half of the 3 factor. Okay, and that might be it, but we don't know. Let's see. 7. 7's a weird one, you guys. I mean, I don't really have a factor rule for 7. I just kind of see 84 divided by 7. Actually, I think, yep, 12. So you got 7 and 12. Well, it turns out there's a lot of factors for this. 7 and 12. 8 will not work because 4 is paired with an odd number. 9. Well, 3 is not paired with a multiple of 3. So 10, 11, not 10, and yeah, we pretty much got it. Now, which combo is going to get you +5? Wow, it's the last one we got there, right? So here we have it, the -7 plus 12. That's the answer to that one. So anyway, this may have just been an excuse for me to review the up the ladder, down the ladder, but it comes in handy. Now, there's another way. Some of you guys, there's an obvious way to do this. You could have, if this was an MCAS question, which it was, right? You could just FOIL each of these and see which one gets you the quadratic that you're looking at right there. So that's another way to do it, right? If you FOIL, anyway, I'm not going to go through the steps there. You guys know how to FOIL. But if you FOIL this bottom one, you would notice that it matches up. Okay, now factoring. Okay, this is an IXL preview, right? Your homework, part of your homework is going to be on IXL tonight. Factoring. Now, the first thing you do, I don't care what you're factoring. Always try to factor out a greatest common factor. This is the #1 move. Always. If there's no greatest common factor, hey, do something else, right? But always try to factor out the greatest common factor, because sometimes that's all you're going to have to do to factor it. Other times, it's not all you're going to have to do, but it's going to make everything else significantly easier. So one of the IXL things is just, what's the greatest common factor? Here it looks like the greatest common factor of the coefficients is 4, and the greatest common factor of the a's is a squared. I always like to think of it almost as 2 separate problems, right? What's the greatest common factor of the coefficient, and then what's the greatest common factor of each of the variables, which I guess is more than 2 problems if you have a bunch of variables, but you guys know what I mean, right? Now, factor out the greatest common factor of a polynomial, right? So you've got to be all factored out of each of the terms, right? So here, there is no, the coefficient, there is no common factor. W is the only thing I can really factor out of both of those. So 5w squared plus 2, right? And that's fully factored right there. That's all I can do right now. So Anyway, it's just something you guys will see in your first couple of IXLs. Okay, and then the next couple of IXLs, what you're going to see is factoring, right, where the lead coefficient is 1, right, where you just simply unfoil it, right? Right, and then you guys are going to go up the ladder, down the ladder to figure out what can multiply to get this and add to get that. Okay? And then this one here, this is where you're going to have to do the box method. Or you could use box method. I guess you could guess and check. I'm sure there's other ways that you could do it. But the way that we taught you guys is the box method. And just because you may have only seen it once in this video, I'm just going to kind of go through it kind of super fast here, right? The easy part of the box method is draw the box, and you got the first and last terms, right? Now, the harder part is now we multiply these two together. That's how we get our 10, right? So just to be clear, that's 2 times 5 is how we got that. And now I just write all the factors of 10. 1 and 10, right? 2 and 5. Okay, which combos add to be 7? Oh, no surprise, it's 2 and 5. So I guess as far as a box method problem, this is about as simple as it gets. But anyway, and then you're still not done. You're going to figure out the greatest common factor here. I got 2x, and I got 5. Right here, it looks like I simply have x, and I have 1. So when I foil this, I'm going to say I get x plus 1, or unfoil it, I guess I should say, and 2x plus 5. Of course, if they were asking you to solve it equal to 0, right, then you would have to go the step further and figure out, well, what value would make this thing 0? It would be -1. And what value would make this 0? Probably be like 2.5 or something, or -2.5. But they're not asking you to do that. They only asked you to factor it, which is what you're going to have to do in that particular IXL exercise. All right, and now whatever it takes, right? You're going to see some more advanced problems under your IXL, right? This one, although it looks hard, it actually is easier, believe it or not, because you got those 4 terms, right? This is set up very nicely for you to use the box method. So this is actually easier because there's no mystery as to what's going in the boxes. This is a slam dunk. That is all about the greatest common factor. I got 8u squared. Here I got 9. Here I've got, I guess u. And here I got 2. Right? So you guys can check my math on this, but I think it's going to be u plus 2, right, times 8u squared plus 9. So yeah, it actually is easier to use the box method when there's 4 terms. And now here, I'm not going to tell you how to do this, but all I'm saying is whatever it takes. Okay, so remember, what's the number 1 move? The number 1 move is always take out the greatest common factor. All right, I lied. I'm going to help you out a little bit on this, right? So I'm looking at my greatest common factor. Every single one of those, I can factor out a 3. T's, every single one of them I could factor out at least a t squared, right? U, okay, using some of them, U's not in all of them, right? But what I just did there by factoring out that 4t squared, right, now I've got something that will be easier to work with. Not necessarily easier to work with, but a heck of a lot easier than what I had before, right? So 10u, okay, and then here we've got 5. Just 5, okay. All right, now it's crazy. You got a whole bunch of stuff here. It's weird, I know, but you got 4 terms. Why not give the box method a shot? Why not see what the box method can do for you, right? Maybe it'll work, who knows? Let's see, we got 4t, u, 2t, 10u, and 5. All right, let's just see. So I got 2t right there. Here I've got 2u. Okay. Here it looks like I just got 1, and here I got 5. All right. Now, you're going to have to check this one yourself here. Let's see. 3t squared, right, times 2u plus 1, 2t plus 5. All right. Will that get me everything that I was hoping for? Well, let's see. You're going to get 4tu, right? Yeah, what the heck? Let's just do it all out. Why not? Why not? You want to see if it's right? You want to know for sure? This is the last thing that we're going to do together today. Why not? Okay, so let's see. So I've got over here checking my work just so you guys can see it's a separate thing here. Right, so you've got 6 t squared u. And by the way, this is a whatever it takes type of problem, right? This is supposed to be confusing. 3t squared, right? Okay. Okay, and then here we've got 2t plus 5. Sorry, my tablet's getting a little funky on you guys. Okay, now let's see if that lead term matches, right? 12t cubed u. Check that off. That matches. Okay, let's see if let's see if my outside terms work, right? 30. Oh, sorry again about that tablet. 30 t squared u. Let's see if that works. Yep. Okay. Let's see those inside terms. 6t cubed. Yep, that matches. And then finally, those last terms. 15t squared. All right, my tablet, I guess it picked a good time to run out of gas because this is the end of it all. But look, it works, right? Now, folks, if you're still looking at this, say, what the heck did we just do there? The point being, right, factoring, whatever it takes. Always start with the greatest common factor, right? And then once you factor out the greatest common factor, then it's time to start looking for quadratics, the box method, right? Difference of 2 squares, if you're familiar with that, right? But number one, always factor out the greatest common factor before you do anything else, because it's going to make the problem, if not possible, significantly easier, right? So anyway, here's some much simpler problems for you guys to do before we see you guys for the next lesson, right? Lead coefficient 1, lead coefficient not 1, so you're going to do something, maybe use the box method. But yeah, you guys, that's it. So I think this is our final lesson for the week, so I look forward to seeing you guys next week. We're going to keep getting after the algebra. Again, I'm Mr. C, and I hope you guys have a good weekend.